Good morning, TMS second graders. I hope that you've all had a great semester this semester. And I have to say that you guys did a great job with your exhibit night last night. Congratulations. I had so much fun watching all of your science experiments. Now, some of you may know me, but I'm James's dad in Miss Bennett's class, and I'm actually a chemist. And so it's made me so excited that you guys are studying something about chemistry. And I just wanted to send on this little video to kind of help clear up a couple of things that you may have heard in the last couple of weeks. So the first thing I want to talk about is reversible and irreversible changes. Do you remember talking about that? It's a really challenging concept because sometimes something can look reversible, but it's not, or it can look like it isn't, but you actually can. Now, one of the things you talked about was that physical changes where you don't change the molecules are usually reversible. And that's true. Like you can take water and you can freeze it and make ice, and you can melt it to make liquid water, and you can go back and forth and back and forth. Or, and I know many of you did an experiment where you did chromatography. Remember where you made your bookmarks? So you took a mixture of the different colors and were able to separate them out. Now, it's going to be a little bit hard to get those colors back off the paper, but believe it or not, we could do it, and we could mix those back together again. So that's a reversible process. Now, ones that aren't reversible, that are irreversible, that can't go back and forth, those are often chemical reactions, but sometimes the reactions that change the molecules, chemical reactions, can go back and forth. And a great example of that is rechargeable batteries. So anytime you have a battery, like in a cell phone or something like that, that you can charge over and over again, there's one chemical reaction that takes place when it gives up its energy to run your cell phone or play your video games. When you plug it into the wall, you can make that one go back again. So you have to do some work on it, but you can have reactions that change the molecules that are reversible and some that aren't. So it's a little harder to tell sometimes. Something else that I want to mention really quick was about the filtering. So you talked about how to separate something. So you made a mixture like salt and water or sugar and water or even those different dyes in a pen and talked about different ways to separate them out. And we did a lot of experiments, and it was so fun to see the results that you got. And I think that you all found that when you filtered with a coffee filter, that it still tasted salty. Because it turns out the coffee filter actually can never filter out salt water. Why? Because it turns out that sodium chloride, the table salt that we used, those little pieces, those atoms that make that up are smaller than water. So we can't get a filter that's small enough to do it. But you know what we can filter out? Oh, there's a lot of stuff we can filter out, and we can separate using filtration. Things like dirt and bacteria and other things like that. And they do that when they go to clean up our water to make it so you can drink it. So they filter it, but then that doesn't get out everything, like the salt. So what do? They do what you did for the other experiment. Several of you evaporated it, or you boiled it, right? You made the water change state. You took it from being a liquid to a gas. And then you can collect the salt, and several of you saw you had salt left on your paper and made some nice salt crystals, or in the pot after you boiled it. And so you can get nice pure salt, which is actually how we get it from the water that we find it in the earth. You can also collect the water. And they showed you an experiment on Tuesday where you put the lid on top of the hot water and the water condensed. It went from a gas back to a liquid. So by just going from one state, liquid, to another, gas, we were able to separate water from salt. So sometimes filters work great if the pieces you want to take out are big. If they're small, like salt, little tiny pieces, then we have to do something else like the filter, the distillation that you did, or going into the vapor state. So that's just a couple things that I wanted to mention, hopefully that make things make a little more sense for you as you study some more science as you go on. And my hope is that I get to see several of you in my class at Emory University at some point, and we can talk about these experiments in even more detail.